We're going to learn how to balance chemical equations, but before that, we're going to have to make sure you know how to count the elements or atoms and the polyatomics. So, for example, when you see a formula like C6H8O7 and there is no number in front of it, you got to assume that there is a number 1 imaginarily there. So that means the coefficient is 1. So here we got to remember that the coefficient will then transfer to all the elements that are listed here. Okay, so then this means that we have 6 carbons, 8 hydrogens, and 7 oxygens. Okay, what about another example? MgOH2 has no coefficient, no number in front, so we always assume that there is a 1. So the coefficient is 1. Now this coefficient always carries for every element or polyatomic. So we have 1 magnesium, but then here we have, and you see this number right here, we have 1 times 2, which is 2 of the polyatomic hydroxide. So we have 2 hydroxides. Now, this next one has a coefficient here. So the coefficient is 2. So we got to remember that the 2 will carry over here and to this polyatomic. So that means I have 2 calciums, and here this polyatomic doesn't have a number after it, so it means it only has 1. So we have 2 CO3s, which is called carbonate. Right, next, this also has a coefficient. It has a 3. So we got to know that it transfers to this and to this polyatomic. So we have a total of 3 aluminums. Now, the question is, Cn is cyanide, and the question is, how many cyanides do we have? This coefficient 3 and this 3 are basically going to multiply. So 3 times 3 makes 9 cyanides. That is how many polyatomic cyanides that we have. All right, the next coefficient is 2. So we got to look here that the 2 will transfer here and to here. So this 2 multiplies by this 3, giving us how many berylliums? That's right, we have 6. Now, here, this polyatomic PO4, we have 2 of them, so 2 times this 2 will give us how many phosphates? It'll give us 4. All right, so now that we know how to count, I want you to pause the video and Google this line right here, balancing chemical equations. It's basically a little simulation, and it's a game that you can play at the end to help you learn how to balance chemical equations. When you're ready, and when the sub says it's time to quit the game, then come back to these notes. All right, so now you got an idea of how to balance equations using pictures, but we can't always use pictures, so we're going to have to learn how to balance equation just by looking at the numbers. Okay, so here are some instructions. you need to have an equation with all the chemical formulas written correctly. This becomes really important later in the unit. See what you have by counting all of your atoms present. So the counting practice that we did earlier is going to come in handy. Now, you're going to use numbers called coefficients to balance the equations so that the total is the same on both sides. Okay, I'm going to do one example and then have you do the next example. Every time you see an arrow here, you want to think of it like an equal sign. Whatever is on the left needs to equal whatever is on the right. Okay, so below this arrow, I like to list out all the elements that we have. So we have the elements sulfur and oxygen. You have to have the exact same elements on the left and the right-hand side. So basically, on the left-hand side, there are 8 sulfurs. On the left-hand side, we have 2 oxygens. Okay, so I'm basically getting it from these numbers right here, 8 and that 2. Now, on the right-hand side, how many sulfurs and oxygens do I have? I have only 1 sulfur and 3 oxygens. Now, when you do a comparison, you can see that 8 and 1 do not equal each other, and 2 and 3 do not equal each other as well. So, we're going to have to make this even. So, when we do that, you need to multiply by a specific number to make it equal on both sides. So, 1 and 8, what is the lowest common factor between 1 and 8? It's the number 8. So 1 times what will get me to 8? So that is going to be 1 times 8. Whatever is in this box, okay, is a number I'm going to write as my coefficient. Now, notice that I'm on the right-hand side of the S, so I need to be on the right-hand side of my equal sign and find where the letter S is. The S is here, so I put the 8 right in front of it. Now, once you put a coefficient here, you have to realize that now you changed the number, the counting number. So this 8 now applies to the S. We do have 8. We wrote that here. But now this 8 applies to this oxygen. So we don't have 3 oxygens anymore. How many oxygens do we have? 8 times 3 is 24 oxygens. So our 8 sulfurs now match, but now we have 2 oxygens on this side and 24 on this side. So we have to do the same logic as before. We're going to have to, we can only go up, we can't divide. So 2 times what is going to give me the lowest common factor? 2 goes into 24, so I'm going to have to jump all the way to 24. So what number belongs in this box? Very good, 12. 2 times 12 is 24. Now notice that I'm on the left-hand side. I'm on the left-hand side of my equal sign, and I'm talking about the element oxygen. So find oxygen on the left-hand side, which is here, and put the coefficient right in front of it. So that would be 12. Okay. Now, double check all your numbers. When you put this 12 here, that's 12 times 2 is 24 oxygens, and there are no other elements that we are touching. So now you do a check. 8 is equal to 8. 24 is equal to 24. That means we are balanced. If you have an empty one right here, you can leave it empty. But if leaving it empty makes you nervous for some reason, you can always fill it with a number 1. Okay? So, I'll start you off on the bottom one, and then you guys try to figure out how this works. So remember, this is your equal sign. You have the elements iron and oxygen. You have 1 on the left, 2 on the left, and here you have 2 on the right and 3 on the right. Okay, this one's a little bit tricky, so I would suggest, my hint is start with oxygen first and see if you can figure out what to do. Okay, so I would pause here and try to see if you can do it. If not, I'm going to go ahead and keep explaining it. And if you got it right, then you can sort of skip all my explanations. All right, so here, 2 and 3 are not equal to each other, so I need to find the lowest common factor between them. So the lowest common factor on both sides is going to be 6. So I can multiply by a number to get 6, multiply by a number to get 6. Question is, what number goes in there? 3 times 2 gets me to 6, and 2 times 3 gets me to 6 here. Now, this 2 right here is on the right-hand side, so I need to find the oxygen that is on the right-hand side. It's right here, and put that 2 in front of the whole thing. Now, once I put that 2 in front of the whole thing, I got to remember that it affects everybody. So 2 times 3 is the 6 oxygens, but now I don't have 2 irons anymore. How many do I have? 2 times 2 is now 4. Okay, now going back to this oxygen over here. Now, this oxygen is on the left-hand side. So where's the oxygen on the left-hand side? It's here. So I'm going to put this coefficient in front of this oxygen. Okay, 3 times 2 is 6 oxygens. There's no other elements affected, so now I don't have to worry. Now, look at this iron. This iron is now uneven. I have 4 on the right and 1 on the left. So this one needs to become 4 so it's equal on both sides. So 1 times what number can get me to 4? 4. So remember, this box is on the left-hand side of iron. Where is iron on the left-hand side? It's here. So I'm going to put the number that's in the box in front like this. So here I can see I have 4 irons and it's not affecting any other elements, so I don't have to worry. And now we do a self-check. 4 is equal to 4, 6 is equal to 6. So the answer is 4, 3, 2. All right. Next, it's the same idea. So once again, I would pause here and see if you can do these on your own. And then press play when you're ready to check your answers. All right, so these were just as easy as the previous ones, so I went ahead and just showed all my work and all my answers. If you have a question, I would ask, and if you understand this, then I would move on to the next page and try 2 more. So the top 2 right here is functioning the same exact way. We just have a little bit of more elements. So I will help you set this up. So you have an equal sign, you have a magnesium, you have a manganese, and you have an oxygen. So you have more elements, but the concept is exactly the same. So try to do these next 2 problems and see if you can figure it out. Pause here and then play whenever you're ready to check your answers. All right, so I would spend some time here checking your answers. If you have any questions, I would definitely ask and get the help that you need. Now, this next section I'm going to help you work on because it's a little bit different. Here we have a lot of 3-element compounds, which means we have polyatomics. Okay, so when there are 3 elements or more, that means that there is a polyatomic. If there's a polyatomic, we want to keep those polyatomics together. Okay, so we're going to do the same thing where we're going to write what we have down the middle. So we have a silver, and if you look here, we have 3 elements. So this is actually a polyatomic. So we're going to keep the polyatomic NO3 together. Here we have 3 capital letters, so we have another polyatomic here, like this. So I'm going to write lithium, and my other polyatomic is hydroxide. So we want to keep those together. So here I'm just going to make my parentheses so it's easier to count and easier to count over here. Okay. So how many silvers do I have? I have 1. Now look right here, the NO3s, there's not a number here, so we assume that there is 1. There is no number next to the lithium, so it's 1. There's no number next to the OH, so we assume 1. Here on the right-hand side, we have 1 silver. There is no number here, so we assume that that is 1 OH. There is no number next to the Li, so it's a 1. There's no number next to the NO3, so we assume 1. So 1, 1, 1, 1, 1, 1, 1, 1. That means that this chemical reaction is already balanced. So you could technically leave it blank, but it bothers some people, so you are more than welcome to throw in some 1s here if that makes you feel better. Okay, so let's try the bottom one. So here we have an iron and a chlorine. We have a beryllium, and we have the polyatomic PO4, which is phosphate. Okay, so now we should be able to clean this up, or count this up rather. So we have 1 iron on the left, 3 chlorines on the left, 3 berylliums on the left, and we have 2 phosphates on the left. So the 3 came from here, 2 came from there. All right, on the right-hand side, we have 1 iron, we have 2 chlorines, that number there, 1 beryllium, and here our PO4 has no number here, so we assume that there is only 1. Okay, so our irons are already balanced, so we move on to the next thing. We have a 3 and a 2. So that means we need to make this equal to the same lowest common factor. 2 and 3 can multiply both up to 6. So I need to multiply by a specific number, multiply by a specific number to get there. Okay, so 2 times what gets us to 6? 3. So we are on the right-hand side of the arrow, chlorine. That's this chlorine here. So we're going to put the 3 right in front. Now remember, when you put that number in front, you affect all the other elements. So beryllium doesn't have 1 anymore. It now has 3. And then 3 times 2 is 6, and that was accounted for. Now let's do the other side. So here, 3 times 2 is 6. So now we're talking about the chlorine on the left-hand side, which is here. So the 2 goes here. Now, remember, when you put a number here, it affects all the elements here. So we don't have 1 iron anymore. We actually have 2. And then 2 times 3 is 6 chlorines. All right. At this point, a couple things happen. Our 6 and 6 are not balanced. My 3 and 3 are not balanced. But my iron back at the top is not balanced anymore. So I need to fix this. I have 2 and 1. So 1 can be multiplied up to 2. So the question is, what should I multiply with so it gets to 2? 1 times 2 gets me to 2. Now, this box is on the right-hand side, so I need to find the iron on the right-hand side, which is here. So I'm going to put that 2 here. Now, when you put that 2 there, it affects everything. So now I have 2 irons, which I accounted for. And now, how many PO4s, how many phosphates do I have now? I don't have 1 anymore, right? I don't have 1 anymore. I now have 2. So now, let's look at all our counts. We have 2 irons, 6 chlorines, 3 berylliums, and 2 phosphates. Now everything is balanced. So we have a 2, blank, 3, 2. You're more than welcome to leave it blank, but if it bothers you, you can always throw down that 1. Okay? Now, the last type of balancing reaction is a little bit tough. So, we're going to spend a little bit more time on the next one. Okay? So, here we go. So this is combustion. All combustion reactions have 3 elements. The 3 focus elements are carbon, hydrogen, and oxygen. I call them the Cho equation. And I call them the Cho equation because I always want you to do carbons and hydrogens first. Every time you see a Cho, CH's and O's, always do C's and H's first. So for example, here's our equal sign. Here is C, here is H, here is O. Okay, so we have 4 on this side, 8 and 2. We have 1, we have 2. And if you look carefully here, you see there's oxygen here and here, so you have to add them up. So 2 plus 1 gets me a total of 3. Now, you're tempted to fix that 2 and 3 first, but like I said, when you have Cho, do your C's and H's first. So let's focus on our C's and H's. Okay, so C's first, 1 and 4. So I can easily get to 4 by multiplying a number. So here I'm going to do 1 times 4. So 4 is going to go where the carbon is on the right-hand side. So my 4 goes here. Okay, now normally we would recount, but I want us to do the C's and H's and then do a recount later. So next we have an 8 and 2. 2 can be multiplied up to 8, so 2 times what gets me to 8? 4. So I'm talking about the hydrogen on the right-hand side, so I put the 4 here. Now let's recount our O's. Okay, so let me get rid of these arrows here. All right, so now 4 times 2 gets me 8 oxygen. So I'm going to go ahead and cross out this 3 because it doesn't exist anymore. So I have 8 plus 4 times 1 gets me 4. That is a total of how many oxygens on the right-hand side? It's a total of 12. Okay, so now I can change this 2 and multiply it up to a 12. And all I have to do is multiply by what number here? 6. Okay, now I'm talking about the oxygen on the left-hand side, which is here. So I put a 6 here. So now everything's balanced. 4, 4, 8, 8, 12, 12. We are good to go. You're always welcome to put that 1 there. 1, 6, 4, 4. Okay, I would pause here and make sure you know how to do the next one. The third one is a little bit different, so wait to do the third one, but go ahead and do the second one on your own. Pause it, and then check your answer. All right, so check your answer. Did you get 1, 3, 2, 2? Okay, if you did, great. That means you did your C's and H's, and then you recount your O's and start over from there. Okay, if you didn't get it, I would definitely go get some help. All right, the last type is a difficult type of Cho problem. So I'm going to do one really, really tricky one, and I'm going to have you guys try on your own. So for example, you're going to still label this C, H, and O. So I count 6, 6, 2. Here I have 1, 2, and I'm just going to leave this blank because we're going to have to recount it anyway. Okay, I'm going to fix my carbons. So I'm going to get to 6 by multiplying. 1 times 6 is 6, so that goes here. Now here I can also get to 6 by multiplying. So that goes there. So I'm going to go here. Now I'm going to count my oxygens. 6 times 2 is 12, plus 3 times 1 is 3. So that is 15. Now, here's where it gets awkward. 2 and 15 are very odd numbers. 2 doesn't really go into 15. But if you had to, right, if we had to go to 15, the question is 2 times what can get us to 15? Do you know? What is 15 divided by 2? You can do it on a calculator if you need to. But 15 divided by 2 is basically 7 and a half. All right, so here, if you put 7 and a half, right, that's not really a whole number here, and so this would be 1. We can't leave it like this because there's no such thing as a half of an oxygen gas. So the question is, how can we get rid of a 0.5? All you're going to do is take each of these numbers and double it. So the 1 actually becomes a 2, 7 and a half doubled becomes 15, 6 doubled becomes 12, and 3 doubled becomes 6. Now you have whole numbers. So the answers are 2, 15, 12, and 6. Okay? You can try the next one on your own, or you can just continue playing while I explain it. If you want to try it on your own, I would do that and just skip to the answer, and you can double check if you got it right. Otherwise, just stick with me. So here's your last example. Here you have CHO once again. 4, 10, 2, 1, 2, and I'm going to recount later. All right, I need to get to 4. So I'm going to put a 4 here. I need to get to 10. So I'm going to put a 5 here. 2 times 5 is 10. Now I'm going to count my oxygens. Okay, 4 times 2 is 8, plus 5 times 1 is 5, which gets me to 13. Now, 2 doesn't evenly get into 13, but I can sort of force it. What is 13 divided by 2? It is 6.5. 6.5 times 2 is 13. So if I do that, I can put 6.5 here and a 1 here. Now, we can't have halves, so all we have to do is double every number. So 1 becomes 2, 6.5 becomes 13, 4 becomes 8, 5 becomes 10. So the answer is 2, 13, 8, 10. All right, it was pretty tricky. Let me just say that all of this stuff is scratch work. So there are a lot of you guys that don't need to do it. Some people can just do it in their heads. That is fine by me. But for the rest of you, writing it all out is really, really helpful. So if you can't do it in your head, make sure you write it out.